All right. So today we are going to talk about direct and inverse variation. This week is more about kind of looking at solving some equations for x and working with exponents. And starting tomorrow, we're going to talk about like functions now on the graph. So we're going to look at the coordinate plane. So next week, we're going to work more on the functions, what's called a radical function and a rational function. We're going to look at them on the coordinate plane in two variables. But this week is more of like solving equations, which I do like. I like the more algebra part of things. All right, so direct variation is not actually part of the standard on this, but I feel like I need to teach direct variation so that we can learn about inverse, because inverse is the most important one. So just remember that. You are going to be, I will probably test you on direct and inverse variation, both, but inverse is the most important. All right, we have a couple of notes to take first. So we're going to first look at direct variation, and then we'll look at inverse. I'm writing this down from your notes if you just want to copy me. So direct variation is a specific relationship in which there's a constant ratio. So our constant ratio will be y over x between all ordered pairs. Does everybody have that written down? Close. I want to do one example, kind of the long way, and then we'll talk about the short way, because these are pretty simple problems. But I want to show you, so if we have two ordered pairs, and the idea behind this is we're going to end up finding a missing value. Okay, so we have a function, okay, we're going to say it's direct variation. So it's of the form y equals k times x. And we pulled two ordered pairs from that function. But we want to find this missing y value. So that's where we set up an equation, we solve for it. So the long way around this would be, we would use our form right here kind of as a setup of what we plug into. So if I have y equals kx, then I'm going to use this first point that actually has an x and a y, and we're going to substitute that in there because we first would need to find that constant of variation. That's a number in our function. So I'm going to put -4 in the y spot and a 2 in the x spot. How could we find k on that? What would we do? So what's the opposite of multiply? So we could divide both sides by 2. So k would equal what? -2? Because -4 divided by 2. So now what that has told us is that these two, or this point, if we know it's direct variation, it represents the equation y equals -2x, because -2 we found was k. So now if we know this point is a part of this function as well, we can say, all right, well, if we have an x of -6, then what's going to be y? Well, we can plug -6 in here. So -2 times -6. And what's -2 times -6? 12. So we could say that y equals 12. But if we're told that, hey, this is a direct variation problem, then we already know that because all your problems have this constant of variation, but we know that they have a constant ratio of y divided by x. Okay, so look at this for a second. What's -4 divided by 2 on that first point? What's -4 divided by 2? That's your k. So then the same thing if I would set up a ratio then. So if I said, okay, I know that -4 divided by 2, I got those numbers from our first point here, that equals my constant of variation. Well, then so should y divided by -6. And hadn't we solved the basic proportion already this semester? Cross, multiply, and solve. So we could say 2 times y is 2y. -4 times -6 is +24. Divide by 2, what's y? 12. So I just gave you two options here. Okay, option 1 is above my line. Option 2 is below my line. Which one do you like better? Option 2. All right. So we're going to start practicing right now. We have a couple problems for direct variation, and they're going to be given to us in different ways, but we're going to use the same steps. We're going to set up a proportion, y over x. Do we have that written down? Wait, can I flip? Okay. So that was number 1. So I'm going to keep going. Number 2 from the slides. So we have a point 12y, and we have a point 47. If we know that this is direct variation, then we know y over x for one point is equal to y over x for another point. Okay? I don't need to label this, but I will just for the first couple examples. So on our first point, we're going to say y divided by 12, because that's our y value over our x value. And that's going to be equal to the y value here, which is 7 over 4. So first step is you set up your proportion. Then we can cross multiply. So y times 4 is 4y. What's 7 times 12? Can somebody help me out? 84. And then we divide by the number in front of y. So we divide by 4. So what does y equal? Very good. And that's all you need to know for direct variation. That's not too bad, is it? Okay, look at number 3. I'm going to write it out. It has a couple more words. It says if y equals negative 18, when x equals 3, find x when y equals 30. So instead of just laying it out in an ordered pair, it's given us a sentence. But we can still do the same thing. So for direct variation, and I will always tell you whether it's direct or whether it's inverse. Okay, so if you're wondering about that. But for direct variation, you set up proportions y over x. So we're going to say negative 18 over 3 because those are together. They relate together. You just want to make sure you put your y value on top. So we're going to say 30 divided by x. So then we crisscross. So negative 18 times x is negative 18x. 3 times 30 is 90. Divide by negative 18. What's 90 divided by negative 18? Negative 5. Are y'all doing okay on this? It's pretty easy. Are you wondering, like, when is it going to get harder? That's all it is. Or number 4 says if y equals 10, when x equals negative 4, find y when x equals 12. All right, so I want you to try to set the two fractions up on this one. So y over x. For direct variation, you always do y over x. You should have gotten 10 over negative 4 equals y over 12. Did you get that? All right, now try crisscrossing and solving for y. You get negative 30. Okay, so the next 4, pretty much it's the same thing over and over, so I'm going to give you a few minutes to practice some. I'm going to write them here. Number 5 are the points 4, 16 and x 24. Number 6, x negative 16 and 6, 24. All right, so take a few minutes and work on those 4 problems for me. I'm going to start putting answers up for them. So as you finish, start checking. All right, any questions on those? Anybody? All right, let's quickly go over inverse variation then. So it's going to be different from direct. So inverse variation is a specific relationship in which there is a constant product between all ordered pairs. So inverse variation is where there's a specific relationship in which there's a constant product x times y between all ordered pairs. Is anybody still writing that? Finishing it up. All right, so on inverse variation, if you look at the equation that I wrote up there, we have y equals k over x. So the way that this k becomes a product is because we would multiply y times x to solve for k. So k equals y times x. So now when we're trying to solve and you're told that it's an inverse variation and you're given your 2 points and you want to find that missing value, we're going to multiply x times y. So x times y equals x times y. So when it's inverse, you multiply those. So we're going to say 12 times 14 equals negative 24 times y. So then I would have to simplify 12 times 14, which is 168. From there, how do we solve for y? Divide. So 168 divided by negative 24 is negative 7. So y is negative 7. Y'all are awfully quiet. Are you following this? So number 2, we have 9y and negative 18/6. So if we know that they vary inversely, then we're going to say 9 times y equals negative 18 times 6. So I'm just getting those from the points there. So the first thing we solve is negative 18 times 6. So 9y equals negative 108. Divide by 9. And y would equal negative 12. And then the same thing you may have where it gives you a sentence instead of 2 points. But you do the same thing. The two numbers that relate to each other, the x and the y that relate to one another, you multiply them. So we're going to say 9 times negative 6 equals x times 3 and solve for that x. 9 times negative 6 equals x times 3. So 9 times negative 6 is negative 54. X times 3, we would write that as 3x. Divide by 3. And x equals negative 18. All right, I want you to try number 4. So if y equals 12, x equals negative 6, find x when y equals negative 24. Do you get positive 3? All right, we're running a little behind today, but I want to make sure that you can practice these. So what I'm going to do is just stop. Let's do 5, 6, 7, and 8, and we're going to pause on this, and we'll finish the other stuff tomorrow. But I want you to finish these problems.